We're going to learn how to construct a confidence interval for population mean when sigma is given to you. If sigma is given, we're going to use z-score. If sigma is missing, we're going to use t-values, step by step. Very good. So first of all, you need to verify that you can identify where sigma is located, and sigma must be given to you. Make sure your sample is random, and either you have a normally distributed population or you have enough values in your sample more than or equals to 30. Find the sample statistics N and X bar. N is the sample size and X bar is the average or mean of the sample. Then you're going to find a critical value ZC that corresponds to the given level of confidence. Find the margin of error E, follow the formula ZC times sigma over square root of N, and finally find the left and right endpoints of your interval. Then you're going to say that, hey, my mu is bounded between X bar minus E and X bar plus E. These are the guidelines that we have to follow when we are constructing confidence interval for population mean. So let us take a look at one example. We're going back to the original example that we did in class. Constructing a confidence interval. Use the data to construct a 95% confidence interval for the mean number of hours worked by grocery store employees. These are the number of hours, and remember that the sigma is given to us as 7.9 hours. Very good. These are the steps that we have to take, right? In following the steps, first verify sigma is given. Remember that in the question, sigma is given to us as 7.9 hours. Well, we don't know if the population is normally distributed or not, but we know that we have 40 data in our sample. So it is more than or equals to 30. So we're good. You can go to the next step. Find the sample statistics, N and X bar. Remember that we did the calculation and we found X bar to be 29.6 hours. In finding the critical value ZC that corresponds to the given level of confidence, you have a 95% level of confidence. For a 95% level of confidence, the critical value is 1.96. And again, to take a look at our calculator, here, if you want to use your calculator, you need to go to second bars and you need to find inverse norm. In the inverse norm, since it's 95% level of confidence, 5% of the leftover area is divided up into half to the left and to the right. That's how you get 0.025. Since it's a z-score, mean is 0 and standard deviation is 1, you can find the area z-score for the area to the left, or you can find the z-score for the area to the right. So if I click on right and then go to paste, it gives me exactly 1.96. That's why you see 1.96 here. The critical value is 1.96. ZC is 1.96. Why we need this? Because we need to find the margin of error. The margin of error is ZC times sigma over square root of N, or 1.96 times 7.9, our sigma, divided by square root of sample size, which is 40. Once we do the calculation, it is about 2.4. So we have the margin of error. Now we can go to the next step. In the next step, we can find the left endpoint and the right endpoint. The left endpoint is X bar minus the margin of error. X bar, as you remember, is 29.6 minus the margin of error that we just calculated is 2.4. The right endpoint, X bar plus the margin of error, or 29.6 plus 2.4, which is 32. So we're going to say the mu, or the population mean, is bounded between these two numbers. What's the interpretation? With 95% confidence, we can say that the population mean number of hours worked is in between 27.2 hours and 32 hours. We don't have a single value estimating the population mean. This is a big population. So we cannot just use 29.6 hours as a single value representing the population mean. Instead, we say that, okay, we are 95% that this number is among these values, 27.2 to 30 hours. And we are 95% confident about that.